Hello everyone. Topic is oxidation of 1 degree and 2 degree alcohol by pyridinium chlorochromate, in short PCC. In previous videos we have covered KMnO4, K2Cr2O7 oxidizing agent, which were bringing 1 degree alcohol first to aldehydic stage. They were oxidizing 1 degree alcohol up to aldehydic stage. That aldehydic stage was further oxidized to carboxylic. 2 degree alcohol we have oxidized by KMnO4 or K2Cr2O7. Firstly, they are going to create ketone, and because they are strong oxidizing agents, further oxidation of ketone will happen, which will lead to carboxylic acid plus alcohol, and alcohol will be further oxidized to aldehyde or even up to carboxylic stage. Means finally 2 carboxylic acid molecules will be generated. 3 degree alcohol in a concentrated sulfuric acid first create alkene, and that alkene is oxidized further to ketone or aldehyde depending on the nature of alkene. Now suppose I want to convert 1 degree alcohol into aldehyde. I don't want carboxylic acid. I want to stop reaction up to aldehydic stage. In this condition, I can use this oxidizing agent, PCC. They are weak oxidizing agents. They will stop reaction up to aldehydic stage. They don't have a tendency to oxidize aldehyde further to carboxylic acid. Similarly, if I want to stop 2 degree alcohol oxidation only up to ketonic stage, I can use PCC. The reaction will start up to ketonic stage. Further oxidation will not happen. If I talk about 3 degree alcohol, let me tell you, PCC cannot work with 3 degree alcohol. It will not react with 3 degree alcohol. So 3 degree alcohol oxidation cannot be done by PCC. You can't use PCC for 3 degree alcohol. Only that's why we have written 1 degree and 2 degree alcohol oxidation by PCC. 1 degree alcohol will be oxidized to aldehydic stage. 2 degree alcohol will be oxidized only up to ketonic stage. Further oxidation will not happen. This is the use of PCC. Now, let's talk about PCC first. Then we will go for mechanism. How that PCC is generated. It is generated by the mixture of chromium trioxide. This is the formula of chromium trioxide. It's a orange color powder, which is reacted with hydrochloric acid, HCl. You can check chromium is positively charged +6 because 6 electrons it is sharing with oxygen, and oxygen is more electronegative than chromium, so 6 electrons are going toward oxygen side. That's why it is carrying positive charge. Between HCl, in HCl, H have a positive charge, Cl have a negative charge. So what will happen? Between H and Cl bond will break. Cl will release out as Cl negative. H will release out as H positive. So Cl negative will attack on chromium, negative will attack on positive. Obviously chromium can make maximum 6 bonds. So 6th bond means pi bond will break, and obviously electrons will shift toward oxygen side. These electrons oxygen will use to make with hydrogen, due to which this compound will generate. Chlorochromic acid. Chlorochromic acid. Now the compound which is generated here, chlorochromic acid, will further reacted with pyridine. What is pyridine? It's a colorless liquid whose formula is this. 6 carbons are there. 5 carbons. 1, 2, 3, 4, 5. C5. 5 hydrogens are there. H5 and nitrogen is there. This one, C5H5 pyridine. It has a base because this lone pair is there on nitrogen. So with the help of this lone pair, it can gain H positive. The molecules which can gain H positive, we can call them base. So it's a base. And what kind of base it is? Such base are known as Lewis base. So when you will mix this colorless liquid with this chlorochromic acid which was generated from chromium trioxide and HCl, you can check here, this H is there. This H is connected with oxygen, and you know oxygen is highly electronegative. So these electrons are strongly shifted toward oxygen. That's why this hydrogen have positive charge. So this hydrogen is working as an acidic hydrogen. It's an acidic hydrogen. It's a nitrogen waiting with a lone pair. So what will happen? H positive will break bond from oxygen. Obviously electrons will shift toward oxygen side. H positive will release out with a vacant orbital. And that will combine with nitrogen. Due to which, okay, directly here I am writing, this vacant orbital and this lone pair dative bond will generate. Out of 2 electrons, 1 electron nitrogen will shift toward hydrogen. That's why this nitrogen will have positive charge on it. Dative bond will generate. Out of 2 electrons, 1 electron it is shifting toward hydrogen, 1 it is keeping with itself. This positively charged cation will generate, which we call pyridinium ion. And here, because oxygen will get extra electron from hydrogen side, so on this oxygen, 3 lone pairs will generate and 1 negative charge, because 1 extra electron of hydrogen it got. Now this negative particle and this positive particle will have interaction with each other, and this compound which is generated over here, in which this particle and this particle have positive and negative interaction with each other, this we call PCC. Pyridinium chlorochromate. It will be a yellow orange color solid compound powder. Now is it ready for the oxidation process? Wait, no, we need a solvent here. This whole compound will be dissolved in a solvent which we call dichloromethane. Anhydrous because it don't have water molecules. It is a colorless liquid. So this whole compound will get dissolved in this, due to which we will have anhydrous PCC ready with us for oxidation reaction. So this is, we have information about pyridinium chlorochromate. Now let's use it for the oxidation of 1 degree alcohol. First I will apply it for 1 degree alcohol, then for 2 degree alcohol. Let's go for the mechanism now. We know general formula of 1 degree alcohol is this. Mechanism is very easy. You can understand it very easily. Now in pyridinium chlorochromate, this is the condition. This negative charge is balanced by our pyridinium ion. There is no role of pyridinium ion in the mechanism. It is just balancing the negative charge of this particle. The main role is of chromium. You can check chromium is connected with 4 highly electronegative atoms, and it is sharing 6 electrons with them. Chlorine highly electronegative, oxygen highly electronegative. So don't you think it will have a partial 6 charge on it? Due to this partial 6 charge, it have a tendency to gain electron. Who can provide electron? alcoholic oxygen. Let's provide. What will happen? Because this oxygen is going to make bond with it, chromium can make maximum 6 bonds. So 6th bond will break, pi bond will break, and pi electrons will transfer toward oxygen side, due to which the new compound generated will be this. Dative bond, 1 electron it will completely transfer toward chromium, 1 it will keep with itself, due to which it will carry a +1 charge. And here what changes will arise, you can check. This one. Now for stability, this oxygen will break bond from its hydrogen, and obviously electrons will shift toward oxygen because more electronegative it is. What will release out? H positive particle, which will attack on these O negatives. Again I am repeating, if I am not writing electrons, write by yourself. Oxygen with 2 bond, always 2 pairs. Oxygen with single bond, negative charge, always carrying 3 pairs. So when it will join with it, I am rubbing it, please note down. The new molecule generated will be this. This one. Now, in this condition, what will happen? This oxygen, which is carrying negative charge. Now, obviously, this particle, this chromium is sterically hindered. What it will do? It will little bit make itself comfortable. How? Like it will bring these electrons here, and the bond which is easily breakable will release out from here. The bond which is easily breakable, let me tell you, between chromium and chlorine it is. Because of bigger atomic size of chlorine, this bond is so lengthy and weak. Chromium bond is with oxygen, you can check, and chlorine. So which bond is easily breakable? Chlorine atomic size is bigger than oxygen, so this bond is lengthy. Lengthy bonds are easily breakable. That's why this oxygen will shift, because obviously when bond will between chromium and chlorine break, these electrons will go with chlorine, because chlorine is more electronegative than chromium. So vacant orbital positive charge will generate, which will be satisfied by this oxygen. Means this oxygen and chromium both will get satisfy each other. So what will generate here? This molecule will turns to and there is a release of Cl negative particle. Now what this Cl negative particle will do? In previous videos we have already understood what we call it. This intermediate is known as chromate ester. Chromate ester. Now chromate ester is full of oxygen, and oxygens are strong electronegative atoms, so they are attracting electrons from carbon side. Because these electrons are going strongly toward oxygen side, so obviously in turn the carbon will start attracting electrons from hydrogen, due to which these hydrogens will get high positive charge, means they will become acidic. Will be attacked by negative particle. In previous mechanisms of K2Cr2O7 and KMnO4, who was attacking on them? Water molecules. Water molecules were breaking in H positive and OH negative. OH negative was attacking. But here, as I told you, solvent is CH2Cl2. Water molecules are not there, so we can't use them. Here, this H positive will be attacked by this Cl negative, because this Cl negative is carrying 4 lone pairs and also it is unstable. So it can attack easily on this H. Means it is working like a base here, Lewis base. What will happen? Bond will break. When bond will break, these electrons will shift toward carbon side because carbon is more electronegative than oxygen. And obviously these electrons we have to shift here for the bond formation, because from this side we are getting electron attracting effect, strong electron attracting effect. Now between carbon and oxygen, second bond will generate. So obviously carbon will break this third bond. And when this bond will break, electrons will transfer toward chromium side. Because these electrons are coming, they will repel these electrons, or you can say they will push these electrons further. So now please check what is generated. This H as it is, between carbon and oxygen, double bond will generate. Please focus on this main compound. This is aldehyde. Mechanism is almost same like in previous cases we have done, K2Cr2O7, KMnO4. Only there is a little change of reagent. Side product HCl and chromium will become this O, double bond, O, OH, and it will get one pair from this side like this. So aldehyde will be generated. Now first I will talk about this aldehyde. Will this aldehyde further oxidized? No. Why? Please check. In previous mechanisms like KMnO4 and K2Cr2O7 when you have used, for its further oxidation, its hydration is important. It was reacting with water molecule H2O, due to which it creates H positive on O, OH negative on carbon, due to which it was creating hydrates of aldehyde. These hydrates of aldehydes were reacting with KMnO4 or K2Cr2O7 for their further oxidation. Means if you want to oxidize aldehyde, you have to make its hydrate. And hydrates are only possible when you have water. But in this reagent, we don't have water. We are using anhydrous CH2Cl2 as a solvent. This is the main point. This is the benefit here. If water molecules are not there, so its hydrates cannot be generated. If hydrates cannot be generated, so further oxidation is not possible. That's why 1 degree alcohol will stop itself only up to aldehydic stage in the PCC and CH2Cl2 as a solvent. This is the important point. And what about these reagents? Let's check what will happen with them. Little bit change and you will get a final result. This is aldehyde generated and a reaction will stop up to here. So this was the whole mechanism. Now if I talk about this HCl and this one. So as you know that HCl is a strong acid, will break in two parts, H positive and Cl negative. H positive will start attacking on oxygen, pi bond will break. So our chromium will convert itself finally into this molecule. Chromous acid we call it. Chromous acid. And the Cl negative, remember which ion we have? Pyridinium ion. In the start I said no? Pyridinium ion is there, which was balancing chlorochromate ion. Chlorochromate ion is used. Now this positive charge of pyridinium ion will be balanced by Cl negative. That's it. In this fashion 1 degree alcohol will oxidize up to aldehydic stage. Now let's go for 2 degree alcohol. If 1 degree alcohol we have understood So 2-degree alcohol, again same mechanism, only little bit difference is there. Let's go for 2-degree alcohol now. This is our 2-degree alcohol. You know what is the condition of chlorochromate? This is the condition balanced by pyridinium ion. This one, this is PCC we have. Let's start the same mechanism again. Chromium carrying +6 charge because 6 electrons, 1, 2, 3, 4, 5, 6. 6 electrons it is sharing with highly electronegative atom. Due to its positive charge, it will be attacked by oxygen. There will be a shiftage of electrons, pi electrons, because maximum it can make 6 bonds. So obviously 6th pi bond will break. You have to shift 1 pi bond toward oxygen side, due to which there is a generation of one unstable particle. This oxygen will become negative because it is getting extra electron. Please write electrons by yourself. Cl is there. Now first this oxygen will stabilize itself by breaking bond from H. H positive will release out, will combine with O, due to which let's draw it here. Due to which this compound will generate. This oxygen will be stable now because it got its electron back. Between chromium and this oxygen dative bond is there. O negative, OH. Now in this condition, this chromium is surrounded by, you can check, by those atoms which are carrying so many lone pairs, and these lone pairs will make it unstable, or you can say simply crowding. So it will make itself better. How? This oxygen is unstable, so it will break a bond with any one atom. Which bonding? It can break easily this bond between chlorine and chromium. This is a weak bond because it's a lengthy bond due to the bigger atomic size of chlorine. So it is easy to break. That's why electrons will start going toward chlorine, because chlorine is more electronegative, and this bond will break. And because electron has gone with chlorine, here vacant orbital with a positive charge, which will be balanced by this oxygen, which is already unstable. So chromium and oxygen both will get stability. And here we have a release of chloride. So this molecule will turns to this. Chloride particle will generate out negative. As I told you, in this, what is this intermediate? This is chromate ester. Chromate ester. In chromate ester, a lot of oxygens are there. So due to higher electronegativity of these oxygens, these electrons are strongly pulled toward them. In turns, this carbon will attract electrons from hydrogen, and this hydrogen will become strongly positive. This positive hydrogen will be attacked by our Cl negative. Bond will break between carbon and hydrogen, and obviously electrons will be shifted toward oxygen for double bond formation, and bond will break. These electrons will be further pushed toward chromium, and here we will have a generation of carbon oxygen double bond. So what will generate? Let's write it here. This compound, what it is? Ketone. It is ketone. And what will release out? That you know, HCl plus this compound, this one. So this is our main product, ketone will generate. And what you have to do with HCl and this compound, that you know already, we have discussed it. Please check the aldehydic portion. Same mechanism you have to apply with that HCl and this compound. Here we have a generation of ketone. Now ketone will further not oxidized. Ketone will not be oxidized. Reason, in previous mechanisms of ketonic oxidation, I told you ketone for its oxidation create enol, and enol will be generated in acidic medium. H positives are required, like sulfuric acid we have used in previous videos. So H positives were delivered by them and they create ketones, and they turns ketones into enol. The enol will further oxidize, but here we don't have such acidic mediums. H positive ions are not available, so ketones will not change itself to enol, and if they are not changing themselves to enol, obviously their further oxidation is not possible. That's why PCC will stop 2-degree alcohol only up to ketonic stage. Further oxidation is not possible because for further oxidation you need to convert ketone into enol, and for that acidic medium is required, which is not available here. That's it. With 3-degree alcohol, PCC cannot react because in 3-degree alcohol you can find there is no such hydrogen. Here hydrogens are required. Please check 1-degree alcohol and 2-degree alcohol. Here hydrogens are required for the oxidation mechanism. Please check. But this carbon do not have a hydrogen. So that's why its oxidation is not possible with PCC. That's it. This is the end of the video. In next videos we will cover